My name is Alex Serrier, and I am Director of Research and Development at Teecom. What am I excited about?
So many things.
So many things. One of the great things about working in research and development is we get to keep a pulse on big picture technology trends, and we are super excited about artificial intelligence and more specifically machine learning and how we can harness it to improve the work that we do, the way that we do our work, and ultimately outcomes for all of our projects. So when we talk about artificial intelligence and machine learning, many of us may think of things like autonomous vehicles or maybe science fiction concepts like HAL 9000 from 2001: A Space Odyssey. But today, our use of machine learning and artificial intelligence, it's much more mundane, and yet it's already all around us. From the digital assistants like Amazon Alexa or Siri and the Google Assistant to the predictive keyboard on your smartphone. We are already interacting with machine learning-based systems on a daily basis, and that means that we all already have experience with it. So when we think about applying artificial intelligence and machine learning to our own industry, the architecture, engineering, and construction industry, we are most excited about the potential to transform the design process and make it much easier, in fact, make it possible to encode our engineering expertise into software. In the past, our approach to these kinds of design tools would have been to define all of the rules that govern the system that we're trying to design, make those rules into a software program, apply some automation, and ideally have something that can generate new designs for us very quickly. Well, it turns out there's a whole class of problems where coming up with all of those rules ahead of time is virtually impossible. And with machine learning, what we can do instead is take our body of past work and basically set the machine loose on that work and have it figure out the rules on its own. And once it's done that, we can now take that learning and have it generate new designs for us automatically. My name is Alex Serrier, and I am Director of Research and Development at Teecom. Working in research and development, we pay attention to all of the technology trends. And one of the trends that we're most excited about is the advancement of artificial intelligence and machine learning. In particular, we're excited about how we can apply these tools to our design process and make sure that they are affecting.
What are you doing?
My name is Tyler Kovacic. No, wait, damn it.
That's a good outtake. I like that.
My name is Alex Serrier, and I am Director of Research and Development at Teecom. As part of our research and development efforts, we are looking at big picture technology trends and how they impact our projects, our clients, and the way that we do our work. One of the things that we're most excited about is artificial intelligence and more specifically, machine learning. The potential for artificial intelligence and machine learning to dramatically change our design process is on the forefront. That's not a great way of saying that. We see a great potential for artificial intelligence and machine learning to dramatically affect our design process. One of the things that we're most excited about is moving away from the past model where all of the automation tasks that we wanted to undertake required knowing ahead of time the rules that govern the final output. With machine learning, the amazing thing is that we can actually feed a machine learning system our past body of work and have it figure out all of those rules on its own. So when we apply that learning to a new project, it actually encodes all of our engineering expertise into that software application. When people talk about artificial intelligence and machine learning today, I think many people think of the science fiction forms of artificial intelligence, the HAL 9000, capable of running a spaceship and locking you out of the airlock. Maybe if you're up on the news, you hear about autonomous vehicles and how that might completely change society. But the reality is our interactions with machine learning and artificial intelligence today are much more mundane. And surprisingly, I think virtually everyone is interacting with machine learning and artificial intelligence systems on a daily basis. whether that's a digital assistant like Amazon Alexa, Siri, or the Google Assistant, or something as simple as the predictive keyboard on your smartphone. These are all machine learning based systems, and we have come to take them for granted. They are part of our daily lives, yet they have a significant impact. So when we think about artificial intelligence and machine learning going forward, we think about these systems infiltrating many more aspects of our lives and becoming an even more regular part of our daily experience. Within the AEC industry, we see three primary impacts of artificial intelligence and machine learning. First and foremost, this potential to dramatically change our design process, where by feeding a machine learning system the past body of work, whether that's from an architect, an engineer, or any kind of AEC practitioner, feeding that into this system so that it can learn on its own how to generate new designs. This potentially saves a lot of time. It potentially makes us much more effective in terms of accuracy. But the impressive thing and the exciting thing is that this is a way of encoding expertise and all of those successful projects that we've delivered in the past into a software application and ensuring consistent output in the future. It also means that instead of taking from 2 or 3 high-resolution renders, high-resolution options that we might present to a client, we can have a machine learning system actually generate an infinite solution space and explore those solutions, picking out the solutions that make the right compromises based on budget or other requirements from a client. Second, we think about the change that's going to need to happen from the Second, we think there needs to be a change in our relationship with finished projects and new work. And the reason for that is that machine learning systems depend on an enormous amount of data. At the moment, when we hand off a completed project, it's rare that we have an ongoing ability to gather data back from those facilities. We might have 1 or 2 post-occupancy studies, but after that, the data just is lost. Maybe the owner captures some of it for energy consumption measuring, but we think that with machine learning and artificial intelligence applications, we're going to need to gather much more data about our projects and ensure that we are capturing the performance data so that we can design better buildings in the future with machine learning systems. And then finally, the third significant impact is on the design of buildings themselves. As we add more and more of these sensors into our facilities, they are going to become capable of generating vast quantities of data and allowing us to further optimize facilities going forward. There's a couple great examples of this already. One in particular is the Amazon Go store, where machine learning systems are able to track people as they go through the store and associate specific actions with actual purchases. We know that every project in the AEC industry is a collaboration. And from our perspective, it's important to engage those collaborators in all aspects of the work. So whether that's being a technology trusted, we recognize that all projects within the AEC industry are collaborations. And fundamentally, Teecom, we see ourselves as trusted technology partners. So whether that's helping to answer questions about the technology systems that actually go into buildings, or helping guide the industry with choices about the design tools that we use and implement. Ultimately, all of this is a collaboration. And we need to partner within the industry to make sure that we are guiding the conversation about artificial intelligence and machine learning so that we can exploit it to its full potential. We know there are lots of unanswered questions about how artificial intelligence and machine learning apply to our industry. In particular, starting with copyright and this idea of using past projects and all of the data associated with those plans from all of those different collaborators to train a machine learning system. Are there copyright issues there? Again, when we think about generating even more data from buildings, who owns that data? How do we protect that data? How do we make sure that the right people have access to that data and not the wrong people? So as we think about these questions, we know we're going to have lots of conversations, and we want to make sure that those conversations happen early so that we aren't caught off guard by developments with this incredible technology. In the short term, we're applying machine learning to some very specific design problems, but we see a grand vision where the design process is fundamentally altered. In the grandest sense, we see a future where you might be able to take a simple sketch of the form of a building, or maybe it's the outline of a floor plan, and have a machine learning system actually populate all of the details necessary to actually build out that space, and do it virtually instantaneously. That future, I think, is much closer than many people think, but that is the kind of future that we see dramatically impacting our work.
Awesome.
We're excited to learn how you think artificial intelligence and machine learning can apply to your work and your firm.
Awesome.
What we've seen in the past with the AEC community is a lack of engagement when it comes to new technologies and new ways of doing work. And we think the risk with artificial intelligence and machine learning is that we'll be left behind, or at the very least, we'll be left out of the conversation. And that's why we think it's so important to engage early and start working on these tools now, shaping the conversation, having the difficult questions answered. All of those things we can start now while machine learning is still such a nascent technology, so that we can harness it to its full potential, and we're not just waiting for a technology company or a software company to give us some fully finished tool. We want to be able to shape those tools. We want to be able to harness their full power and ultimately be in control of them. At Teecom, our research and development group is focused on building tools that will allow us to harness machine learning and artificial intelligence for our own design output. Within our research and development group, we have a couple of folks focused on these tools and testing them now to ensure that machine learning can be applied to our specific discipline. Beyond our discipline, though, we think there's a ton of potential for machine learning to improve all aspects of the design process within the AEC community. We recognize that all projects within the AEC industry are collaborations, and we see ourselves and have always seen ourselves as trusted technology partners. We recognize that all projects within the AEC industry are effectively collaborations, and to that end, we see ourselves collaborating across the industry. We have always seen ourselves as trusted technology partners, whether that's for the technology systems that go into projects or the design tools that we use every day. To that end, we want to partner with architecture firms and really any practitioner within the AEC industry to ensure that machine learning systems are used to their fullest potential, and we can ultimately shape how they evolve and how we use them in our practices. We know there are lots of unanswered questions when it comes to how we harness the full potential of machine learning and artificial intelligence. Some of those questions revolve around copyright, around terms and conditions in contracts, data governance, how we actually manage all of this data that we're generating, what it means to have a past library of projects, and how we use the data from that library to differentiate ourselves in the future. There's tons to explore here, and we think that having a conversation within the community is critical to the future success of our industry. My name is Alex Serrier, and I am Director of Research and Development at Teecom. At Teecom, our research and development group is tasked with understanding big picture technology trends. And one of the trends that we are most excited about is artificial intelligence, and more specifically, machine learning. We are incredibly excited about the potential for machine learning and its impact on our projects, our clients, and the way we work. In particular, we are looking towards machine learning as this significant enhancement to our design process, where in the past we have experimented with various ways of automating parts of the design process. The way that we've tried to do that is by building rule-based systems. Effectively, here's a rule to govern the placement of a specific outlet, or when you have a room of size X, this is the kind of display that you put in that room. But with machine learning, it's a completely different paradigm. With machine learning, instead of defining all of those rules ahead of time, we just give the system our library of past work, and it figures out those rules on its own. My name is Alex Serrier, and I am Director of Research and Development at Teecom. Our research and development group, they are tasked with understanding big picture technology trends and how they will impact our projects, our clients, and the way that we do work. One of the developments that we are most excited about is that of artificial intelligence and more specifically, machine learning. Of course, we are always interested in delivering our projects more quickly, more efficiently, and more effectively. But the way that we've tried to do that in the past has been rather difficult. In the past, we've tried to develop rule-based systems that would allow us to automate various aspects of our design process. But with machine learning and artificial intelligence, instead of trying to come up with all of those rules ahead of time, we can just feed these systems our past library of work. And Teecom, we've been in business for quite a while, so we have a vast library of past projects that we can feed to a machine learning system. And once we train that system on those past projects, it can actually generate design rules for us. And that means that future projects, we can actually encode all of our expertise, all of those successful projects into this software application so that it can help us design successful projects in the future. This is a huge shift in the way that we work. Another way that machine learning is going to significantly impact our design process is by taking data from our existing projects, that is the live data being streamed out of these buildings, and actually allowing us to use that to impact the design of new projects. This, again, is a significant shift, but with all of these Internet of Things devices being connected and generating data of some kind, now we can harness that data and actually use it to influence the designs for the future. In thinking about how machine learning is going to affect our design process, obviously we want to be able to deliver projects more quickly. That is a goal of virtually any research and development effort. But in terms of how that actually affects the way that we work, what we're most excited about is returning time on our projects to the actual valuable work that we do. Because while drawing lines and placing symbols is a critical part of delivering successful projects, ultimately it's not the valuable part of our work, or it's not the most valuable part of our work. The valuable work that Teecom does is having conversations with our clients to understand how technology systems can ultimately support their needs and benefit them through their projects. If machine learning can handle some of the mundane tasks associated with placing symbols and drawing lines on construction documents, that means more time for us to have deep conversations with our clients to understand what they really need and how our solutions can benefit them. Obviously, we know about how we are going to apply machine learning to our design practice, but we're really excited to learn about all the different ways that other firms are going to harness the power of machine learning and artificial intelligence to benefit their design process and the ultimate outcomes of their work. We're excited to hear about the many different ways that other firms besides Teecom are going to harness machine learning and artificial intelligence in their own design practice. We can't wait to hear about your projects.
Action?
We know that our perspective on the AEC industry is incomplete. We know there are lots of challenges across the industry from a design standpoint, and we can't wait to hear from you about the various projects that you're working on and how artificial intelligence and machine learning might help you solve those problems more quickly. We want to work with you so that you too can harness the power of machine learning and artificial intelligence to solve the problems that you have, whether that's a design challenge or an operational challenge, anything that we want to hear from you about the challenges you're facing and how we can partner together to harness machine learning and artificial intelligence to solve those challenges. We want to hear about the challenges that you're facing and how we can partner together to harness machine learning and artificial intelligence to solve those challenges. My name is Alex Serrier, and I am Director of Research and Development at Teecom. Teecom's research and development group is focused on the big picture technology trends that will have an impact on our projects, on our clients, and the way that we do work. We are very excited about this trend of machine learning and artificial intelligence and how we can harness it to deliver our projects more quickly and effectively. But beyond that, we're excited about the potential for machine learning to give us a way of encoding our Beyond that, we are excited about the potential for artificial intelligence and machine learning to give us a way to encode our engineering expertise into a software application. This is a huge change from our past approaches to encoding engineering into software. When we think about artificial intelligence and machine learning today, many of us probably imagine 2001: A Space Odyssey's HAL 9000. This is the omniscient artificial intelligence that can run a spaceship and lock you out of the airlock. That may seem like science fiction, but the reality is that we are dealing with artificial intelligence systems on a daily basis already. Granted, they are much more mundane. They take the form of the predictive keyboard on your smartphone or the voice recognition system that powers Amazon Alexa or the Google Assistant. These are our day-to-day interactions with artificial intelligence and machine learning. But as the technology progresses, we expect that artificial intelligence and machine learning will find its way into more and more aspects of our daily lives. Within the AEC industry, we see three potential impacts of machine learning and artificial intelligence. First and foremost, we think there's going to be a significant change to the design process. Fundamentally, this comes from machine learning's ability to take a vast quantity of data, namely past projects, encode that information into a software application, and then allow us to generate new designs virtually at zero cost. So where in the past we might have spent a ton of time on 3 or 4 high-resolution renders to present to a client, today, or rather in the future, with machine learning and artificial intelligence, we'll be able to generate an infinite number of solutions. And we'll be able to select from those solutions the designs that best suit our client's need or make the right trade-offs from a budget or constructability standpoint. Second, we see machine learning and artificial intelligence requiring a new relationship between our finished projects and new work. And what I mean by that is that because machine learning depends so much on data, we need to have access to the data being generated by the facilities that we're designing. That means new contractual relationships and new mechanisms for funneling that data into our systems so that we can harness it and ultimately leverage it for future designs and future machine learning applications. Finally, in terms of artificial intelligence's impact on the design of buildings themselves, we are already seeing facilities that are operated almost entirely by machine learning systems. The best example of that is the Amazon Go store, the first grocery store without cashiers. It uses machine learning systems to understand who is within the store and make sure that as people are picking stuff off the shelf, they are assigned those items and ultimately charged for those items when they leave the store. This is a fantastic example of machine learning systems shaping the design of facilities. And not only that, it's a great example of the amount of data that can be generated by a new facility and ultimately harnessed by machine learning systems. Many times when we talk about artificial intelligence, the fear is that these are systems that are ultimately going to take jobs. But when we think about how artificial intelligence is actually going to be applied within the AEC industry, we see it much more as a partner. When we talk about artificial intelligence today, many people think immediately that these are systems that are going to take jobs. Fundamentally, we disagree with that perspective, especially within the AEC. When we talk about artificial intelligence today, many people immediately jump to the conclusion that these are systems that are going to take jobs. Fundamentally, we disagree with that perspective. We see the application of artificial intelligence and machine learning within the AEC industry as a significant design enhancement. This is a tool that can be deployed to enhance our creativity, not take it away. And because our industry is so dependent on creative solutions, we think that artificial intelligence and machine learning will ultimately make that creative process better, faster, and potentially cheaper. When we talk about artificial intelligence today, many people immediately jump to the conclusion that these are systems that are going to take jobs away from people. Fundamentally, we disagree with that perspective. We see machine learning and artificial intelligence systems as almost kinds of digital partners that can enhance the design process. Today, much of the work that we do and much of the time is spent on the mundane aspects of design work. That's literally placing lines and placing symbols in construction documents. But when we think about it, that's not the most valuable work that we do. The valuable work that we do as practitioners in this field is understanding clients' needs and translating those needs into something buildable. Well, if we can offload the mundane aspects of that work, placing the lines, placing the symbols, and spend more time actually having conversations with our clients, that means we can better understand their problems and ultimately deliver better solutions. At Teecom, we're excited to incorporate machine learning into our design process. We're starting with a very narrow application, and that specifically is the design of telecommunication systems. But this start, we think, is a great example of the potential for machine learning, where what we've done is given a machine learning system access to our library of past projects, past telecommunication systems that we've designed, trained it on those systems, and now we're able to use this trained system to help us design new telecommunication systems in the future. These domain-specific tools are just the start. We're excited about expanding these tools so that they encompass greater and greater portions of our design and delivery process. Everything from design verification to actual field verification can all be enhanced with machine learning systems. To help talk about the potential for these systems, we've actually founded a group called Architecture Ex Machina, where we want to engage practitioners from throughout the industry to help understand how people see machine learning systems impacting their work. We want to engage practitioners from across the industry to understand the kinds of problems they have and how machine learning systems might help solve those problems. We recognize that every project within the AEC industry is a collaboration. That's why we think it's so important to engage architects and other design professionals to talk about the kinds of problems that they have and how machine learning systems might be harnessed to solve those problems. We recognize that machine learning and artificial intelligence prompt many questions about data governance, about copyright, about security. There's all kinds of interesting questions to be discussed and answered in the future. This is part of the reason that we think it's so important to engage collaborators. We need to have those discussions and answer them before we get ourselves into trouble. We're still in the early stages of developing artificial intelligence and machine learning applications for the AEC industry, but because we're still early, it's that much more important to start the conversations now and shape how these tools are developed. We don't want to wait for a startup or a technology firm, a software company, to just come along and give us a fully finished tool that they think will serve us. We want to be able to shape those tools as they're being developed. That's part of the reason that we have a research and development group, and that's part of the reason that we want to engage you, is to have these conversations and shape the tools early in this process. Today, we have some very specific applications for machine learning. In the future, though, we see machine learning expanding to all aspects of our work. The science fiction future of potentially taking a simple sketch of a building, maybe just the outline of a floor plan, and having a machine learning system fill out and populate all of the details necessary to actually build that space, that future is going to be here sooner than most people think. We're building tools today for a specific engineering discipline, but the future where we can have this tool that allows us to have those kinds of dramatic changes in efficiency is very near. With the incredible potential of these tools, we know there are lots of problems that we haven't even thought about yet that could be solved with machine learning. We want to hear about the problems that you have and how we can harness machine learning and artificial intelligence systems to solve those problems. My name is Alex Serrier, and I am Director of Research and Development at Teecom. Our research and development group, they work at the cutting edge to understand how big picture technology trends are going to impact our projects, our clients, and the way that we work. One of the trends that we are most excited about is artificial intelligence and machine learning. The development of these tools has the potential to significantly impact the AEC industry in its entirety. Within our own practice, of course, we are interested in harnessing machine learning to allow us to deliver projects more quickly and efficiently. But beyond that, one of the things that we are most excited about is that machine learning potentially offers a way to encode our engineering expertise into software. In the past, the way that we've tried to do that is by coming up with rules-based engines that would allow us to automate certain aspects of the design process. With machine learning, however, instead of coming up with those rules in advance, we simply give the machine learning system access to our past library of work. In our case, Teecom has been around for 20 years. We have a huge library of past projects to reference. We allow the machine learning system to train on that data, and now it can actually help us design projects in the future based on the knowledge that it has learned from those past projects. So instead of coming up with all of these design rules ourselves ahead of time, we allow the machine learning system to do it for us. That is a huge shift in the way that we think about computing problems. Now, instead of needing a quantitative analysis of all of our design work, we can actually just turn the machine learning system loose, and whether it's a quantitative problem or a qualitative problem, it can figure out the relationship, the rules that govern the future output. And this is a huge change. As we add more and more sensors to the buildings that we design, we're going to generate even more data about our projects. Here again is a fantastic opportunity to apply machine learning. If we can take the data generated by the projects that we've worked on and use those to figure out which projects were successful, as we add more and more sensors to the buildings that we design, they are generating even more data about their performance. Here again is an opportunity to apply machine learning systems, where instead of referencing our past library of work, they're actually referencing live data coming out of projects that we've built. The machine learning system can then take that data, determine which aspects are performing. As we add more and more sensors to the buildings that we design, they are generating even more data about their performance. Here again is an opportunity to apply machine learning systems, where instead of accessing a past library of floor plans and designs, they're actually accessing live data about the performance of a facility. If we let them train on that data, they can figure out which features of a building allow for the highest performance, and that means that can be incorporated into our future designs automatically. When we think about how machine learning systems will enhance our workflow, it's easy to see the fact that they will make certain aspects of our work much faster. But that's only one part of the story. What we're really excited about is the fact that by making the mundane aspects of our work faster, we can return a lot of our project time to speaking with our clients and having deep conversations about their needs and how the solutions that we're developing can actually fulfill those needs. This, we think, is the ultimate potential of machine learning, taking over all of the mundane aspects of design work, from drawing lines on a plan to placing special symbols, taking that over so that all of our talented creative engineers can spend more time with our clients and develop solutions that better suit their needs. When we think about applying machine learning to our design process, obviously one of the significance. When we think about applying machine learning to our design process, one of the clear benefits is going to be speeding up certain aspects of our work. But what that really means is removing the tedious aspects of our work from our normal design process, handing that over to the machine learning system, and returning more project time to the valuable work, the creative work of understanding our clients' needs and how the systems and solutions that we design ultimately fulfill those needs. If the machine can spend all of its time doing the mundane aspects of our work, putting the symbols on a plan or drawing lines and making sure everything is aligned neatly, that means our creative, talented engineers can spend more time interfacing with clients to understand their problems and how we might be able to address those problems. Within the AEC industry, we have access to a lot of tools, but many of those tools are not ideally suited to our design practice. The incredible thing about machine learning is because it does depend on this library of past work, there's much more opportunity to shape how these tools ultimately fit into our industry and our current workflows. No longer do we have to adapt our practice to suit the specific limitations of a tool. Instead, we have a much more general purpose tool that can be applied broadly to many different Instead, we have a general purpose tool that can be applied to many different kinds of problems. Previously, they would have taken hours, months to build solutions in a rule-based approach. Today, with machine learning, we can have a machine learning system train on these data sets and have something valuable in a matter of hours. In contrast to many of the tools that we use in our design practice today, machine learning is an incredibly flexible application. Simply by providing it a large data set, we can train machine learning systems to do valuable work for us. There are lots of problems that we have where we have lots of data, but we don't necessarily have the rules that would allow us to design a tool to solve that problem. This is where machine learning comes in. Given that data set, it can figure out those rules for us and give us a valuable tool very easily. As we think about the grand future vision for machine learning, one of the things that I keep coming back to is this idea of ultimately being able to take the sketch of a building, or really the sketch of a floor plan, the outline of a floor plan, being able to feed that into a machine learning system and having it automatically generate all of the features and details necessary to construct that space. All of that could happen virtually instantaneously. And if we didn't like that first design, we could tweak a few parameters and have the machine learning system generate a whole new design instantaneously. That future is not as far off as most people think. I wouldn't be surprised if we can. As we think about how quickly machine learning systems have advanced, one of the things that I keep coming back to is the eventual future where we can take a sketch of a building, or maybe just the sketch of an outline of a floor plan, feed that into a machine learning system, and have it generate all of the details necessary to actually build out that space. That may seem like pure science fiction today, but that future is far closer than most people realize. As we think about how quickly machine learning systems have advanced, one of the things that I keep coming back to is a future where we can take a sketch of a building, or maybe just the outline of a floor plan and a few high-level design parameters, feed that into a machine learning system, and have it generate a complete design package on its own automatically, instantaneously. That may seem like pure science fiction today, but that future is far closer than most people realize.